Okay, new unit, unit 2. The directions say solve the equations for the variable. Okay, now if you're in a packet, you don't have to write the directions. Make the box. So you've got x plus 7 equals negative 11. I don't have a number to put in for x because that's my job, is to find what number goes for the x. Okay. I mean, is it 3? No, because 3 plus 7 is 10. Okay. I mean, so if I just guess, it's going to take forever, but there's got to be a better way. Now, an equals has two sides, this side and this side. You want to put a wall on the side where the x is at. And what are your operations on that side? Well, it's just a plus. If it's a plus, you just circle the x. And you need to get this 7 here to a 0. So you're going to put a 7 underneath it, and you need to get a positive 7 to a 0. Well, to get from positive 7 to 0, I go to the left. So that means subtract 7. Okay? So I line up the equals. You're going to want to get in the habit of that. So over here you got x, 7 minus 7, 0, so we can cross that out. And then negative 11 minus 7, that's no different than adding negative. I'm not going to make this up. You can make it a plus negative 7 if you want to. But really, when you're at a negative number and you're subtracting a number, you go to the left. 7 units. 1, 2, 3, 4, 5, 6, 7. I'm at negative 18. Okay, now to check your answer, plug negative 18 in for x, add 7, and then I'm going to click equals, and it should turn out as negative 11, which it does. Okay. Next one, 8 equals x minus 2. So put a wall on the side of the x, the side of the equation that contains x. This time you have a minus operator, so make that a plus negative, please. And circle the x, just like you did. Now you made it a plus. Now, how do you get a negative 2 to 0? Well, from negative 2 to 0, you'd have to travel to the right. So when I'm traveling to the right, that's addition. So over here, I'd had to get the number to 0 by moving to the left. But here, to get the negative number to 0, you move to the right, which we're going to use addition for. So negative 2 plus 2 is 0. And I go over here and add 2. Because an equation's like a balance. What you add to one side, you have to go over and add to the other side. It's like a weight bar. Okay? This is one side of the bar. Everything over here is the other side of the bar. So line up your equals. 8 plus 2 is 10. You got x. Negative 2 plus 2, that's 0. Okay, so x equals 10. So I can go over here and take 10 minus 2. I know that's 8. Okay, next one. X minus 2 equals negative 6. So again, the x is on this side. We have another minus operator, so plus, negative, and then I circle the x. Okay, I got to get this negative 2 to a 0. So to get a negative 2 to a 0, you would go to the right, which means you'd add 2. And then I go over here and add 2. So line up your equals. You got x. Negative 2 plus 2 is 0. So you negative 2. 2 to the right, that's 0. Negative 6 plus 2. 2 to the right, that's negative 4. So there's my answer. Now to check your answer, we can put negative 4 in for x, minus 2, and it should be negative 6, which it is. Okay, next problem. Negative 18 equals m plus 12. Just because it's a different letter, that doesn't mean anything. So we're over here, and the operator is a plus. So I circle the m. I need to get the positive 12 to a 0. Well, I'd have to go to the left, which means I would subtract 12. And then I would subtract 12 from negative 18. So I line up the equals. Negative 18 minus 12. Well, if I'm at negative 18, I go 12 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 30. And over here I just have m. So again, if I put negative 30 in for m and add 12, I'm at negative 18. Okay, f plus 10 equals negative 10. So my variable's on this side with a plus operator. So I circle the f. I get my 10 to a 0. This 10 here, not this one. This is the one I'm trying to get rid of. Okay. So it's positive 10. I go left to get to 0. So that would be subtraction 10. And then subtract 10 over there. That's not 0 because you're at negative 10 and you're subtracting 10, so you're going 10 to the left, not inward. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 20. Okay, to verify the answer, we can take negative 20 plus 10, and that's negative 10. Okay, negative 1 equals x plus 5. So the x is on this side of the equation with a plus. The only operator I have is a plus. Okay, so I just circle the x by itself. Now I have to get the 5 to a 0. Well, to get from a positive 5 to a 0, you're going left. Left on the number line means subtraction of 5. I go over here and subtract 5, so I line up the equals and I have x. So if I'm at negative 1 and I subtract 5, that's 5 units to the left, which is negative 6. To verify our answer, we can take 5 plus negative 6, or no, sorry, negative 6 plus 5, negative 1. Okay, next problem. Negative 20 equals 5 plus x. So x is on this side. Make the wall. The operator's a plus, so when the operator's either is a plus, we circle the x. When it's a minus, we do the same thing. We just make the minus a plus negative. Okay, we have to get this 5 out here to a 0. So the 5 out there is positive, so to get it to 0, I would move to the left, which means I would subtract 5, because that makes 0. Then I subtract 5. Equals negative 20 minus 5. If you're at negative 20, go 5 to the left, you'd be at negative 25. 5 minus 5 is 0, and then we have x. Okay, next problem. Negative 2 equals negative 3 plus x. Okay, so we're over here on this side of the equation. The 3 and plus, there's a plus operator. Okay, so we just circle the x by itself. Get the negative 3 to a 0. So to get from a negative to 0, we would have to perform the addition operation, adding 3. Line up your equals. Negative 2 plus 3. 1, 2, 3. I'm at 1, and then I have x. So x equals 1. Okay, next page. Now the game changes. 3x equals negative 48. So I make the wall. Now there's no operator between the 3 and the x, so that's a times. Now, when I have unlike when I had a plus and a minus operator where I just circled the x, when I have a times operator, I'm going to circle the entire operation. Okay, I'm going to circle the number that's multiplied along with the x. Don't just circle the x. Now, with times and divide, you can put the number line away. You don't worry about that. What's the opposite of times? Divide. So, you're going to divide both sides by the factor that multiplies the x, which is 3. Both sides. Now, here's why I do that. I'm going to randomly pick a number, 3 numbers. I'll go 17. If I were to take 17 and times 3 and divide by 3, I'm going to wind up back at 17. So it's like the times 3 divide by 3 cancels. And I'm going to take 26. 26 times 3 divide by 3. 26. I'm going to take 1003 times 3 divide by 3. I'm at 1003. So no matter what x is, if you times it by 3 and divide by 3, it's going to wind up as just x. Now over here, negative 48, negative divided by a positive is a negative, and that's 16. Okay? So 3 times negative 16, is that negative 48? Yes, it is. Okay, next problem. Negative 98 equals negative 7x. So the x is over here. between the 7 and x, that's a times. So when I circle, I don't circle just the x. I circle the number times x. See, on this first page, we didn't have a times operation. It was just a plus or a minus, so I just circled the variable. Now when I start getting times operations, I want to circle the number that x is being times by. So the opposite of times is to divide. And the factor that's times by the x is -7. Because I have a lot of people that don't remember, well, maybe I'll put the -98 underneath there. No, you won't. You put the factor that's multiplied by x, which is -7. So line up the equals. Over here we have a negative divided by a negative, making a positive. 98 divided by 7 is 14. Then if I'm just taking an x and timesing it and dividing it by the same number, we wind up back at x. So 14 equals x. So over here, let's take -7 times 14. -98. That's the answer. Okay, next one. -4.4 equals -4x. Between the 4 and the x is times. So I don't circle just the x. I circle the -4 times x. So now the opposite of times is to divide. And we want to divide by the x multiplying number, not the one over here. That's the one that's got to go. -4. Line up the equals. So over here you got -4.4 divided by -4, 1.1. Over here I have x, but I'm just timesing it and dividing it by the same number. So now x is by itself. So x is 1.1. So I'm going to take -4 times 1.1. -4.4. Next, we got 2.8c equals 4.2. Okay, there's the 2.8 is a number. Between that and c is multiplication, so I want to circle that. The opposite of multiply is to divide. To divide, we make two lines, because that's operation means division. And we put the 2.8 under each line. So I line up the equals. So on this side I have a c times a 2.8 and then divided by a 2.8, which means that would go away and I just have c. But on the other side I got 4.2 divided by 2.8, and that's 1.5. Okay, to check my answer, I put 1.5 in for c, 2.8 times 1.5. That should be 4.2, which it is. Okay, next one we got -3x equals 108. So here's the x, okay. 3 in the x, that's multiplication. So if I have multiplication, number line doesn't work. I need to underline both sides and put -3. So these divide and times by -3 cancel, and I have x, positive divided by is a negative is a negative. 108 divided by 3 is 36, -36. And you can always take -3 times -36, and that's positive 108. Okay, 4x equals 27. So between the 4 and the x, that's a multiplication. So the opposite is to divide. So I underline both sides and put 4. It's like you're undoing the times by dividing. X, and then 27 divided by 4 is going to be 6.75. Okay, -5x equals 15. So that's another multiplication operation. Remember, so you underline both sides, -5 goes underneath. Line up your equals, you got x, positive divided by negatives, and -15 divided by 5 is 3. -5 times -3 is 15. Okay, -2x equals -14. Wall, the operations times, so I divide by the -2 factor, because that's a factor I'm trying to unmultiply from the x. So we got x, -14 divided by -2 is 7. So let's recap what we've done so far. So if I have a plus or minus operation, okay, if it's a minus, you want to make it plus negative, but then you just circle the variable by itself and get the number with it to a 0, okay? Either by adding if you would have to move to the right to get to 0, or subtracting if you have to move to the left. Multiplication's a different ballgame, okay? You put away the number line, you don't use that, okay? Then you do the opposite, which is times. Now, next page. I have x divided by 6 equals 8. So x is over here. So the x and the 6 have a division operation. Now, like multiplication, we want to circle the division operation along with the x. So what's the opposite of divide by 6? It'd be times 6. So I make my own dots on each side and put 6 and 6. So line up the equals. So you have a variable x. You're timesing it by 6 and dividing it by 6, which means those cancel. And you have x. 48 times 6 is 48. Now if I put 48 in for x, 48 divided by 6 on a calculator, that's 8, or in my head. 16 equals x divided by 8. So x is over here with the division. So like multiplication, you want to circle the division operation along with the x. Then we times and times by 8 and by 8. So 8 times 16 is 128. And then taking an x, timesing it by 8, then dividing it by 8, we'll take it back to x. Again, I'll repeat why that is. I'm going to pick 47. If I would times by 8 and divide by 8, it's going to be 47. Okay, negative 9 equals x divided by negative 3. So x over here, the operations divide. So we do the opposite, which is times. So when you're timesing and dividing, you times by the same factor that's x is being divided by, which is negative 3. So line up your equals. Negative times a negative is a positive. That's 27. Those cancel, and you got x. Don't be switching the negative 3 to a positive 3. You're not on a number line. Okay, you need to use the exact same thing. Okay, next one. N divided by 10 equals negative 22. So I got divided by 10, so I circle the n along with the division of 10, just like I was doing with the times. So the opposite of divided is times by 10. Okay, taking a variable times and divide by the same number takes us to the solo variable. Negative times a positive is a negative. 22 times 10 is 220. That looks a little odd, but if I take negative 220, replace that with n, divide it by 10, that's going to be negative 22. Now, don't let these next problems mess with your head. You got 3/5 n equals 12. So I'm over here. So you have a division operation. A fraction means it is division. I'm not actually going to divide it, but I have a dividing operator, and then the n's not part of the fraction. That's a times operator. So you're going to circle all the times and dividing into one circle. Okay, the opposite of times is to divide. So when we're dividing, we underline each side and put the factor 3/5 underneath the dividing line. So over here, I'm taking an n, I'm just timesing it and dividing it by the same factor, so that's n. Now you can go 12 divided by 3abc5 and get 20, or you can take 12 over 1 and put times, but then flip the bottom fraction. If you change the division to times, you would just reciprocate the bottom to 5 over 3. 12 times 5 is 60, 1 times 3 is 3, and that's 20. Now, if I take 3/5 times 20, I should get 12 if I did it right. Yes, I did. Okay. Next one, negative 4 equals 2/3 b. B's over here. Divide and then times. So I circle all the division times in one thing. Then the opposite of times is divide by 2/3. Just like if that was a 2b without the 3, I'd be putting a 2 underneath there. I put 2/3. So over here I just have the b. Negative divided by positive is a negative. You can do 4 divided by 2ABC3 on a calculator. That's going to be 6. Or you can take 4 over 1 times 3 over 2. That's 12 over 2, which is 6. 12 divided by 2. Okay, 5/8 x equals negative 15. Got times. So again, with times you want to circle it. We need to divide by the factor of 5/8. Okay, it's going to be a negative. And 15 divided by 5ABC8 gives me 24. Again, you could go 15 over 1 times 8 over 5. That's going to be 120 over 5, which is 24. Okay, last one before we get to some easy word problems. 1/4 x equals 2/5. So x is over here with a times, so you want to circle the times. Opposite of times is divide by the fraction 1/4. Just like if it was a 4, I'd put a 4, so if it's a 1/4, I put a 1/4. Okay, you can go 2/5 divided by 1/4, 1 3/5, or you could go 2 over 5 times 4 over 1. Now that's 8 over 5 if you do it that way, but 1 3/5 and 8 over 5 are the same thing, okay? I'll accept either answer, or 1 3/5. Okay, now you got some easy story problems. You don't need to make a bunch of boxes with these. I want you to use street math here. I'm going to use splitting up. On a quiz show, a contestant was penalized 250 points for an incorrect answer, leaving the contestant with 1,050 points. How many points did the contestant have before the penalty? So points equals. You don't. There's only the points is the only label that's important in this problem. So I don't make all the boxes and the graph and the table and all that. Let's use some street math. So he had some points. He got penalized 250, and then after he got penalized 250, he was at 1,050. So we're backtracking it. Okay, penalized means he was minus, but if I'm backtracking, I do the opposite of the minus, which is to add. That's 1,300. So he had 1,300 points to start with. Then he was penalized. Then he ended up with 1,050. Get a party of 102 people, 17 pounds of baked potato are served. Find the people each pound of baked potato served. So people per pound, okay? Finding the per is simple street math. You just take the people, 102, divided by the pounds, 17, and it's 5, okay? Over the last 220 years, the U.S. Constitution had 27 amendments. How many amendments per year were made? So amendments per year. Again, that's the same here, but you got to be careful. You got to put the amendments first. You don't put 220 first. You put 27 amendments first, divided by 220. Round to the nearest hundredth, 0.12. Now you're wondering, that's a weird answer. Well, in the last 200 years, they only made 27 amendments. So that's less than one amendment per year. Okay? So that's why it's such a small number. Much less than one amendment per year. Okay, last problem. Jeremy mowed several lawns to earn money for camp. After he paid $17 for gas, he had $75 left over to pay towards camp. How much did he have before paying for the gas? Similar to this. He's got money, which we don't know what he starts with, but then he pays 17, which now he has 75. Okay, so when he paid, it's subtracting, but when I'm going backwards in the problem, I add. So 75 plus 17. That's $92. Okay, and then you get the rest of the problems.